Bismillahirrahmanirrahim. Dear students, today we are going to discuss atomic structure, and this topic is related to atomic masses, charges, and location of the subatomic particles. If we talk about the relative masses, charges, and locations of subatomic particles, protons mass is 1, neutrons mass is also 1, and electrons mass is negligible, 1 over 1840. And if we talk about the charges, proton is positively charged, electron is negatively charged, and neutrons are neutral. Protons and neutrons are located in the nucleus, so they become the part of the nucleon number, while electrons orbit around the particular shells or in their particular orbits. Now the question is, how do protons behave when you pass it through an electric field? Protons, because they are positively charged, so definitely they are deflected towards the negative plate in an electric field. So how do neutrons will behave when you will pass it in an electric field? Definitely, as they are neutral, they will not be affected by any electric field because they are not having any charge. So now what will be the behavior of electrons while passing through electric field? Electrons are deflected towards the positive plates because they are negatively charged, and this deflection is greater than the protons because electrons are smaller in the mass, and so they are more speedy, and they will show more deflection towards the positive plate. Now, where is the most of the mass of an atom concentrated? Most of the atomic mass is concentrated in the nucleus. Like if you check the periodic table, calcium atomic number or proton number is 20 and atomic mass is 40 point something. So if we talk about its total number of electrons, protons and neutrons, but before that, do check, this shows the proton number, and this is the nucleon number or the mass number, and definitely this is the name and this is the symbol for any element. Now atomic number is representing total number of protons because atomic number means proton number, and these protons are the part of the nucleus. So atomic number is definitely same for each element. If the particles are of the same element, every particle will have the same atomic number, so it will be same for the all atoms of the same element, and it is fixed, exact, and cannot be changed. When the atom is neutral, means when there is no charge on the atom, the atomic number is exactly equal to the number of protons. So total number of protons are when exactly equal to the total number of electrons, there is overall no charge. So mass number is representing actually total number of protons and neutrons in the nucleus of an atom. For example, if we have an element with 10 protons and 10 neutrons, so protons plus neutrons overall make nucleon number, that would be 20. So if the question is that for the calcium atom, calculate total number of protons, neutrons and electrons, we know that 20 is representing the proton number, 40 is representing the nucleon number, and number of neutrons mean A minus Z. Out of 40, if you are subtracting 20, you will get neutrons 20. So overall atomic number is 20, so proton number or atomic number 20 means there are 20 protons. Calcium is neutral, so whenever any atom is neutral, total number of protons are exactly equal to the total number of electrons, and mass number 40 means that if you are going to calculate number of neutrons, subtract 20 from the 40, so answer will be 20. So isotopes, what they are? Atoms of the same element with same number of protons, and definitely if they are the atoms, even the electrons are same, but they have the different number of neutrons. So overall we may define isotopes, atoms of the same elements with same atomic number but with different atomic mass due to different number of neutrons. Symbols, which symbols are used to represent the isotopes? Usually you know that whatever is the element, we have its particular symbol, and atomic number and mass number can be represented in any way. So let's talk about the orbitals. Orbitals, definitely the region where electrons can be there, and they are with the opposite spin. Total 4 orbitals, s, p, d and f. Let's describe shapes of the s and p orbitals. S orbitals are the spherical ones and the p orbitals are dumbbell shape, and subshell means that when the electron shells are further divided into different orbitals, they are actually s, p, d and f orbitals. So let's discuss the rules when we are going to fill the electrons in these orbitals. Electrons always occupy the lowest energy orbital available, so generally they will pair up only when there are no empty orbitals, otherwise they will prefer to live alone, because if electrons are going to be paired up, it means there are no empty orbitals available. So how many orbitals and electrons are there in each type of subshell? We know that subshell S, that is the first orbital, can occupy maximum 2 electrons. P subshell, further if we talk about P subshell, or total 6 electrons it can occupy in the 3 boxes are the orbitals, and for the D subshell, as it can occupy maximum 10 electrons, so we will show them in the 5 orbitals like the 5 boxes, and F maximum can hold 14 electrons, so overall 7 orbitals will be made. So let's compare the relative energy levels of s, p, d and f orbitals. Let's compare. We will say that s is having the lowest energy, f is having the highest, and if f is not there, then d is having the highest energy. So subshells from 1 to 4, how many electrons can be there? Let's check. S, if the shell is first one, the subshell is called S, and it's the one and only shell, subshell present in first shell, and it can occupy maximum 2 electrons. And second shell, it has 2 subshells, S and P. In S we may have 2 electrons, and P can occupy total 6 electrons. So overall in the second shell, total 8 electrons are present, 2 in the s orbital and 6 in the p orbital. Now if we talk about the third shell, that is third one, so it can occupy maximum 18 electrons, because s, p and d subshells are there. S holds 2 electrons, p holds 6 electrons, and remaining ones 10 are in this subshell D. And for this fourth one, it has 4 subshells. So first shell is having 1 subshell, second 2 subshells, third 3 subshells, fourth 4 subshells according to this. So fourth one can occupy maximum 32 electrons. So what is the actual order of filling of the subshells? If you check, this is the filling order for the subshells. Do follow the arrows. 1s, then arrowhead should go towards the 2s. Then when the second s has been completed, you will fill the 2p orbital first, and remaining ones will be resided in the 3s orbital. And still, if you have the electrons available, you will fill 3p orbital first and then go towards the 4s, but when from the 4s more electrons are available, you will not go to the 4p. First you will fill the 3d subshell, then towards the 4p and 5s. In the same case 5s, after 5s filling, you are not going towards the 5p, you are filling 4d first, then 5p and 6s, and 6s still if it is filled and still you have the electrons available, and after this 5p you are going not towards the 5d, rather towards the 4f, then 5d, 6p and 7s will be filled. If they are also completed, then 5f, 6d and 7p orbitals will be filled. Let's write the electronic configuration of calcium. Calcium atomic number is 20. In the first shell, its subshell is S1 and occupies 2 electrons. So 1s2. Second subshell is S again, can occupy 2 electrons. So second S also 2, and 2p6. Second in the subshell 2p, 6 electrons can be occupied, and if the shell number is third one, it has 3s, s will occupy 2 electrons, and p will be filled with the 6 electrons, and remaining will be added in the 4s. So overall configuration of the calcium will be 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. So principal quantum number, actually it tells that how many electrons can be occupied. If the principal quantum number is larger, it's with the higher energy level and it's away from the nucleus, and vice versa. So periodic table can be divided based on the subshells into 4 major blocks: S block, P block, D block and F block. S block is first and second shells groups are there for the alkali metals and alkaline earth metals, both are the metals, and P block can have metals, non-metals and metalloids, and D block is the outer transition metals, while F block is the inner transition metals group or the block. So when we talk about the ionization energy, especially first ionization energy, it means that minimum amount of energy needed to remove an electron from each atom in 1 mole of the gaseous atom to make 1 mole of gaseous ion, that is the cation. So when you are going to provide the energy to ionize the outermost electron, so what do you think, should it be exo or endothermic? It's endo, because energy is going to be absorbed. So successive ionization energies, when you tally with the group within a group, how do successive ionization energies tell you which group an element belongs to? This depends upon the proton numbers available. So if you look for a large increase between two different successive ionization energies, a large jump will be between the 7th to 8th ionization energies, because if there are 7 electrons in the valence shell, so the outermost electrons actually tell the group number, so accordingly you may have the number of shells and subshells available. So what is the trend in first ionization energy? When you talk about this trend across the periods, especially period 2 and 3, generally as you go along the period, first ionization energy increases because size of the atoms is decreasing. The attractive forces from the nucleus with the nucleus and the outermost electrons are bit higher, so ionization energy values are also going to increase. And so overall we will say first ionization energy values increase because of four reasons: as effective nuclear charge is increasing, radius of the atom is decreasing, distance decreasing, shielding effect is up to some extent it may be higher, but overall actually electrostatic forces of attraction are increasing because no new shell is going to be added. So overall these forces